Hello guys, this is Samadan Kale and welcome to all of you on my YouTube channel. So guys, in this video we are going to see the practical number 11 of the third year BSc Mathematics of the subject Python programming. So guys, before starting the today's video, if you do not subscribe to my channel, please subscribe it and press the bell icon so that you will get the latest update of videos. So let us start the video guys, and please guys like my video. Yes, so start it. So this is the application of the numerical integration, and this application of numerical integration based on the unit number 5 of this 5.2, 5.3 and 4 points. Okay, so let us take the first question of this practical guys. What is the first question? Explain the trapezoidal formula to find the numerical integration in Python. Okay, I'm zooming it so that you will be understood it and seen very clearly. Okay, so in the field of numerical analysis, trapezoidal rule is used to find the approximation of definite integrals in the particular interval. Okay, so by using the particular function, by using the given function, we can uh, trapezoid it and calculate the area of the given function. So this is the formula in mathematics guys: integration from a to b f of x dx, and this approximately equal to b minus a into f of a plus f of b upon 2. Okay, so this is the formula. Now for more accurate result, we have the graph. Okay, from this the graph is divided into the n segments of the equal size as shown below. So what is this graph guys? I'm reducing the size so that you will be seeing the figure. Yes, so let's go down. Okay, let us see this figure guys. Yes, so this is the interval a to b. Okay, from this interval a to b, this is the graph of the function. Yes, you can see it. You have to draw this diagram on your sheet. Now I'm zooming it. 1 second. Yes. Yes. I have to go up. It's too zoomed. 1 second. So it's okay. Now grid spacing or segment size. So we have to give the size of the integral, that is h is equal to b minus a upon n, and therefore the approximate value of the given integral is by using the trapezoidal rule. So this is the approximate value guys. Integration a to b f of x dx is equal to b minus a upon 2 into n, and this into f of a plus 2 times summation of f of a plus I into h plus f of b. So this is the approximate value of the given integral guys. So I have given the example, and this is the formula to find the trapezoidal integration by using trapezoidal rule. So any integration by using the trapezoidal rule in the given interval. So I have defined here the trapezoidal function, and here you have to give guys a and b. So what is this a and b guys? This is the limits, upper limit and lower limit. A is the lower limit, b is the upper limit, and n is guys trapezoids. N means trapezoids. In how many trapezoids you want the integral. Now we have to find the h. H is given here, b minus a upon n. So I have used here h is equal to b minus a upon n. Now I am finding this s. S is equal to y of a plus y of b. So what is y guys? Y is the function. Yes, y is the function that we have to define. So y of function's value at point A and at point B. So let us say this is a, f of a and f of b that we have given in the initial f of a and at the last f of b. This one and this one. Okay, that we have to add them. And for this middle 2 into this, we have to define the while loop on I. Okay, I is equal to 1 while this I is less than n. while is I is less than n. That means, guys, what? uh, for n it is f of b, so it should be less than n. So s plus equal to 2 into y of a plus I into h. Okay, what does this mean, guys? Yes, value of s is equal to s plus this 2 into y of a plus I into h. Let us see this: f of a plus I into h, f of a plus I into h. Okay, y means function f, guys. Okay, so this is we have to increment, and I plus equal to 1. That means i's values also increment, and return finally what we have to return: h upon 2 into yes, h upon 2 into yes, means this one, guys. This is the h that we have defined. What is h? B minus a upon n, b minus a upon n. And what is yes? Yes is this, guys. This is we have to define, that is yes. Okay, so this is the formula, and I'm defining now one function, y function, 1 upon 1 plus x into x, that is 1 upon x square. So I run it, and I'm using this trapezoidal 1, 0, 1 and 6. That means I want the trapezoidal integration of the function 1 upon 1 plus x square by using the trapezoidal rule in the interval 0 to 1 with 6 trapezoids. Okay, that means I have divided this interval 0 to 1 into 6 part. Okay, so if I want up to the 4 decimal, this value up to the 4 decimal or 5 decimal, then I am using this format. What is format, guys? This is the format. Remember this format: percent, 0.5 up, and percent 0.5 up you have to give into the string, and then percent. Okay, you can use it. So this one, cut it. Okay, cut it, and use this one. Okay, cut it also. Yes, back it. Yes, here, and trapezoidal, and let's run it, guys. So you will get up to the 5 decimals. Let us see 1, 2, 3, 4 and 5. If you change here 4, okay, so you will get the value of integral up to the 4 decimal places, 7, 8, 4. Okay, guys, I hope all of you understood the first question. Next, second question: complete the following program for Simpsons 1/3 rule, guys. Okay, so I have to complete this program. So I'm copying this program, guys, and paste it here. Okay, in the next cell, and we will complete it. So they have defined this Simpsons 1/3 function, that is Simpsons 1/3. Okay, and in this function we have to enter the function yup. Okay, then a means, guys, the lower limit, b is the upper limit, n means the number of intervals that we have divided this a and b, and h, value of h is float a b minus a upon n. Now see, guys, if you do not study the numerical analysis, please see these formulas. What is the Simpsons 1/3 formula? What is the trapezoidal rule? What is the Simpsons 3/8 formula? Okay, and then you will be able to learn these functions. Okay, I have defined from that formulas these functions. Okay, let us see that formulas first, and then apply this. So result is equal to f of a plus f of b. Okay, same, and here they have used the for loop. So for I in a range 1 to n, this value of k is, I'm going to take now, the value of k is a plus I into h. What, guys? A plus I into h. Then and only then it will be satisfied. That means we have to add this a here. Okay, now if this I upon 2 equal to 0. Okay, if this I upon 2 equal to 0, we have to given the 4 spaces, guys. Okay, and here also we have to give the 4 spaces. Okay, and this also 1, 2, 3, 4. Okay, and it will go to the here. Now here result is equal to result plus 2 into result plus 2 into f of k, that I have to write. That means it will go back f of k, this k. Okay, it will find the value of f of k, and else In the else part, we have to write this result. Okay, result is equal to result plus. Okay, I'm taking this into there. Okay, now this return is here. Now result is equal to result plus what into f of k. So I have to add these 4 times. Okay, I have to add now this 4 times, not 4 times, sorry. Here, yes, here we have added 2 into f of k. So here we have to add the 4 times. 4 times odd terms and 4 times even terms. Okay, 4 times odd term. What is this? Iy2 equal to 0. This is for even terms. That means 2 times this f of k value, and for odd terms 4 times f of k value. And then finally, result is equal to result is equal to we have to multiply it by h upon 3. Okay, you have to see first the formula guide, formula for the Simpsons 1/3 rule in mathematics. If you have seen that formula, you will be able to learn this formula in Python. Okay, so what we have to do here, result into h by 3, result, okay, into h upon 3. This is we have to given here, and then return the result. So if we run this indentation float, where yes, here we have defining the function. Again, I have to give the four spaces for all. Okay, for all lines, and then and only then the program will be run. Okay, this is very simple, guys. Yeah, if you learn the numerical analysis in mathematics, and if you know all these formulas, then you can easily understood this function. Okay, you can easily understood the function. Let's run it. It's run. Now if I want to find the integration of, suppose I want to find integration of sin x. Okay, so I'm using this Simpson. Okay, Simpson, and 1 3 1 3. Now I'm going to enter the function. Okay, suppose I want not sin x, I want x square. Okay, so I'm writing x square. Okay, and then x square, 1 second, x square, and in this x square I want the interval 0 to 1. Okay, and n we have to given, suppose I want this into 6 intervals, the 0 to 1 interval into 6 part that I want to divide. Okay, and let's run it. So what's x is not defined here. Okay, so firstly we have to define the function. We have to define the function. So what I'm going to take, 1 second, I'm defining the function here. So I will use def keyword. Def is f of x. Okay, f of x, and then this return what I have to return, guys, x square. Okay, so x, not capital one, small one, x square. And if I run this, now again what happening here, x is not defined. Okay, I will copy this code from here, control x. Now run it. It's defined now. Now in the next cell, I'm going to call the Simpsons 1/3. Okay. Again, the name x is not defined. Yes. Now here, what I have to do, guys, I have to do the yeah. And if I run this, so I will get the value. I will get the value. So this is the approximated value. Next, what is next, guys? We have to approximate the area beneath y is equal to sin x on the interval 0 to pi using the trapezoidal rule with n is equal to 4 trapezoids. Now what I have to do, guys? We have defined the trapezoidal rule where here. Okay, I will copy the same code. I will copy the same code. Yes, same code, and paste it here. Where I'm pasting here, guys. Okay, let's paste it and run it. So it will be run. That means the trapezoidal function is defined. Now what we have to do, guys? We have to approximate the area beneath sin x, area beneath the sin x. Now I want to define this function sin x. I want to define the function sin x. So for defining the sin x, guys, you can use simpy library or numpy library. Okay. So I'm using the numpy library. So I'm using import, or you can use simpy library. Import simpy as sy. Okay. Import simpy as sy, and then in this simpy library, the sin x function is defined. Okay. So you can define the function now. Def this function now y. Okay. This y of x, this sy dot sin x. Okay. Sy dot sin of x. So this is the function, guys. And if we run this now, it will take some time for importing the library simpy. And then function will be defined, and then you can use the trapezoidal rule. Okay. So firstly, we have to define the function here, and then and only then we can apply the trapezoidal rule to this function. Okay. Now it's defined now. Now I am going to use the trapezoidal rule. So in the trapezoidal rule, what I have to give? I have to give trapezoid. Okay. Trapezoidal. Okay. Trapezoidal, and in this I have to give AB. So what is A, guys? A is 0, and what is B? B is NP dot pi, or SP dot or SY dot pi. So this is defined in this library, simpy library. Okay. And N, number of intervals, N's value is 4, guys. Okay. And if I run this, so what I'm getting error? What is error? Y of A, unsupported, non-type. Okay. Plus it is not supporting to A and B. Okay. So instead of this pi, sy dot pi, I will use here. Where? Here. This B is equal to, I'm using sy dot pi. Okay. And then I will use this B here. And let's run it, guys. Let's run it. So again, it will give me error. So 1 second, I will take it into the numerical and then run. So guys, this is the function that I have defined. So I return np dot sin x. This is our function sin x, and in this trapezoidal abn. Now why I'm using the float here, guys? Why I'm using the float? Because this our b is in the floating number. It's not integer. That's why I'm using the float function. And then this I'm changing the code now. Instead of yes, I'm using the r now, and instead of y, I'm using the f now. Okay. You can write it. Then k is equal to f of a plus I into h, and then r is equal to r plus 2 times f of k. This r1. Yes, this r. Same formula, and then return the r. Now, if I want to find the integral of this sin x, so I'm using a as 0, and then b as np dot pi. Okay, numpy library, and then I have to write this r is equal to trapezoidal of abn, and then print the r. Okay. And at the starting, I'm importing the library numpy. Okay. Import numpy as n. Okay. So from this library, I'm taking the function. Yes. So this is our function. No module name numpy. Yes. What's the numpy? Numpy is small n. Okay. Not capital N. It's a small. Okay. And now run it. So we will get some output, that is 1.89611 and so on. Okay. So let's move to the next question, guys. Fourth question. So the same question. So I'm copying the same code and paste it here. Just change the values of a, b and n. Okay. Just change the values of a, b and n. So control C I'm using, and then here paste. Okay. Now you have to write the function. So what is the function, guys? So it is x cube. So I'm writing this as x cube, okay, and then minus 5x, okay, 5 into x, then minus 9. So this is our function f, guys. Okay. Now where I have to change, yes, limits. So what is our lower limit? 0. And what is the upper limit? That is 3. Okay, that is 3. And n, what is the value of n is, guys? Firstly, it's a 5. Okay, it's the 5. Now here I'm cut the float number. Okay, and let's run it. So we will get minus 28.44 for n is equal to 4. Now if I am using n is equal to 100, if I am using n is equal to 100, then it will be also worked. Okay, so it will give me for n is equal to 100. Okay, so what you have to do, guys, for n is equal to 5, you have to write one code, and for n is equal to 100, you have to write the another code. Okay, here itself same. Okay, so only replace the value of n here. Now nextly is Simpsons one third. Now I'm copying the Simpsons one third methods code. Okay, so that we will find the integral by using the Simpsons one third. Okay, so this is our Simpsons one third, guys, that we have defined. Let's copy it and paste to our question so that it will take. Okay, so I'm pasting the code here and run it. Now what the function is, guys? What the function is 1 upon 1 plus x. Function is 1 upon 1 plus x, and integration from 0 to 1. Okay, so I'm using the function define this f of x. Okay, f of x, and what is the I want to return 1 upon 1 plus x. 1 upon this bracket 1 plus x. Okay, and let's run it and call the function now. Okay, what is the call function, guys? Simpsons 1 3. Okay, so I'm using now Simpsons, okay, 1 3. Okay, 1 3, I have to write 1 3, and then I have to give the function f, and then 0 and 1. Okay, that is the interval, guys. Let us see, this is the interval. Simpson 1 3, and 0 to 1 is the interval. And what is the value of n? N is the 6, guys. So I have to use the 6 here, and this, yes, I want to cut. Okay, and let's run it, guys. It will give us the value. So this is the fifth example. Next, sixth example. Evaluate the integration from zero point 0.5 to zero point 0.1 of the function cos x upon x into dx using the Simpsons 3 by 8 rule. What, guys? Simpsons 3 by 8 rule. Use it by taking the sixth intervals. So Simpsons one third I have here. Now I am using Simpsons 3 by 8. For Simpsons 3 by 8, now I will change the Simpsons one third. I will change the Simpsons one third rule so that I want to get Simpsons 3 by 8. So instead of Simpsons 1 3, I am using here Simpsons 3 8. Okay, Simpsons 3 8 function. Okay, so function that I don't want to give here function. Okay, so I will not give the function here. A, B, and N, these are the three parameters of the function Simpsons 3 8. Then h is equal to, I'm going to use this float b minus a upon n itself. R is equal to f of a plus f of b. That means that the result. Okay. Now for I in a range 1 to n, that is also as it is. And the value of k is a plus I into h. That is also as it is. Now if I is equal to this, that is also as it is. Okay. And else this part is as it is. Again, now I will add some part. I will add some part after the else. So what that part is, guys? That part is r equal to I'm going to use r into, that means result. Okay. So result equal to result equal to result into, yes, result into, I have to use this 3 into h by 3. Okay. 3 into h by 3. So 3 then into, this is the h upon 3. Okay. So this is I want to write, and then finally I will return the code here. I will return the result here. Okay. So this is the thing. Let's run it. If I run this, so it's run. Now I have to define the function, guys. I have to define the function. So firstly we have defined the we have imported the library. So I'm defining the function now. Define this f of x. Okay. So f of x, what is our function, guys? This np dot, yes, np dot cos x, np dot cos x, and it's upon x. Okay. And let's run it. It's run. Now I will call the Simpsons 1/3, sorry, 38. Okay. So Simpsons 38, and in this Simpsons 38 I'm using the value of a as 0.5, value of b as 0.1. Okay. 0.1, and the number n means here we have to take 6 sub intervals. So 6 I am going to take, and if I run this, so I will get the error. So we will check what is the error. Result is equal to f of a plus f of b, the same thing that we have taken for the trapezoidal one. Okay. Model numpy has no attribute cos x. Okay. So here for sin x, what we have taken, let us see, and then we will take it. Okay. So where that example, yes, np dot sin of x. So we are going to see np dot cos of x. Okay. You have to give the bracket here. So I'm going to give the bracket to the cos of x. So this is cos of x upon x. Let's run it, and then run it. Again, it will give the error for f of a plus f of b. Okay. So I will check it. What's going on? So guys, let us see. So I have defined the function in itself here. Okay. Don't take that function outside the cell. So take that function inside the cell. And then I have defined the Simpsons 38. Same code, guys. Nothing is there. No, nothing rocket science is there. Okay. Same code. But what we have replaced, guys, here, result plus 4 times f of k. So what we have to do? We have to do result plus 3 times f of k in the Simpsons 3/8 rule. Okay. So this one line we have to change, and the code is as it is. So this is your answer, 3.9148 and so on. Okay. So this is the Simpsons 3/8 rule. Yes. So I will show this in fully. Yes, this is the code, guys. Now let's take next question. So find the approximate root of the function x into e raised to x minus cos x in the interval 0 to 1 by using the false position method. So guys, this false position method already we have seen in the previous practical. So you can use the same code that I have taken there. So I am running the function now, and I'm only taking here the value of the function y. Okay. Then I will define f of x. Okay. F of x, and then I will write it as x into, yes, x or return. So firstly, I have to write return. So return, what is the function, guys? 1 second. Return. Oh no. Return. Okay. Then in the return, we have to write x into now exponential, na? E raised to x. So I'm going to use the numpy library np dot exponential, okay, exp of x, okay, and then into minus np dot cos of x, okay. So np dot cos of x. So this is our function, guys. And if I run this, the function is defined. Now I'm using the regular falsi method. Regular falsi method. So in the regular falsi, what we have to guys give the guys, we have to give the x0, x1, okay, and the error. Okay. So falsi, regular falsi. So in this, what is the x0 and x1, guys? X0 is a 0, x1 is 1, and error we don't have given. So we will use the error, some error. Okay. So 0, comma 1, and I'm going to use 0 point, okay, 0.00001, and let's run it. Okay. So we will get the iterations, and this is our final answer. Okay, guys. I hope all of you understood the practical number 11. So there is only one practical remaining. I will come with another video. Thank you for watching the video.